Working on a lot of little projects this week, hopefully tying up some loose ends on our vintage Carnival ride restoration. Now, I actually recorded this first segment a long time ago, but I don't honestly remember if I ever shared it or not. I don't think that I have, but either way it's quick, so we'll just get right to it. If you've been following the channel for a while, you might remember when we rebuilt the electric motor that was originally on the ride. Ever since I've done that, there's just been something about it that's just not sitting right with me. That motor has what's essentially a go-kart clutch on it, and that really makes no sense with an electric motor because unlike a gasoline engine where you can give it more gas and that clutch will tighten up, with an electric motor it comes up to speed almost instantaneously and that thing is just going to grip and that's the end of it. The other ride I have does that with a liquid-filled clutch that's kind of more like a torque converter. It's meant to do that. I think we really need to switch to just a VFD with a three-phase motor where we can set an acceleration ramp and a deceleration ramp. And I have this VFD that I won at an auction several years ago. This is a brand new 1 horsepower VFD. It would be perfect for the ride. I just need to find a motor for it now. So after making that decision, I put the call out to family and friends, letting everybody know that I was looking for a motor. I spent some time on eBay and Facebook Marketplace, but I never really found exactly what I was looking for, so finally I pulled the trigger and just bought a new motor. So this is a brand new WEG 1 horsepower 3-phase motor in the box. The mounting foot is a little bit different, so we'll probably have to change the way it mounts to the ride, but that's no big deal. Next thing we need to do, though, is find a pulley to replace that go-kart clutch. I need to try to figure out what the gear ratios are here. So I've got to count how many teeth are on this sprocket. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
20. 30, 40, 50, 60, 70, 80, 90, 91, 92, 93, 94, 95, 96.
All right, it's 96 teeth. Okay, now we need to find out how many teeth are on the sprocket that drives that. All right, so let's talk a little about what's going on here. This is the gearbox for the ride, and it has an input to output ratio of 9.66. So it takes the input speed and divides it by 9.66. This is the output sprocket that's going to drive the big chain sprocket on the ride. This has 14 teeth. And then this is our pulley that's going to go on the input shaft. So we should be able to take all these ratios and calculate what size pulley we need on the output of the motor to get us to our 10 RPM ride speed. So after some careful calculations, we come up with a pitch diameter approximately 2.42 inches, and that's what we've got right here for the output of our motor shaft. Any slight variations we can now tune with the VFD to get just the output speed we want. So on to the next thing. So now that we know what motor and drive we're using for this, I can start designing the electrical panel, and that's actually one of my favorite parts of the whole project. This is not the right size breaker, but we'll use it as a space holder. These 2 lighting relays for the floodlights and the chasers. Maybe this should be at the bottom. And then this is our filter. Our drive. We need room for terminal blocks down here. Yeah, that'll fit. Power needs to come in here, but this works better over here. And then we're going to need something for our control cable. This electrical panel is one we salvaged from an old piece of industrial equipment about 2 years ago. That's going to go right at the very top, centered between there. Lately I've been using self-tappers for this kind of work, but decided I'd go back to drilling and tapping them. Well, that looks like Swiss cheese. This workbench is a mess. I can tell it's not my workbench. Let's do some tapping. I do believe we've got them all. All right, I'm going to wipe it all off. We're going to lose all of our marks, and then I'm not going to know how it goes back together. Starting at the top. Next this again. wrong hole.
That's what she said.
Yeah, we need to get 24 volts down to here. We need a piece over here. So this is going to have to get cut off. All right, executive decision. We're going to re-drill these for Allen head cap screws, which are going to be 1/4 20. All right, change of plans. I don't really like the way this is laid out. Matter of fact, I wish it was laid out the complete opposite way. So I think what we're going to do is take everything off and move it to the back. This may seem like a lot of work for no reason, but I think you'll see once I'm done what it is I want to do. It'll all make sense when I'm done. If it doesn't make sense, then I'm not done yet. The big puzzle is going to be trying to figure out what all these holes are from the back side. At least with those 4 big holes will give me a frame of reference. Yeah. This is going to go here now. Okay, so why did I rearrange this panel? To create a more logical left to right flow. Power comes in at the top left and exits at the bottom right. I wanted the VFD in the bottom right, not because it changes how anything works electrically, although it does keep the high current carrying wires out of the middle of the panel, but just to make the layout easier to understand at a glance. For me, it's all about visual clarity when you open the panel. This is quite a bit more complicated than the original electrical panel. Some of that is due to increased safety expectations, and some of it is due to increased functionality. Okay, time for some viewer mail. Brian reached out to me a while back, said he had a package for me, hoped I could use it. I had no idea what he was sending. I know he does control panel stuff, so I thought maybe it was some surplus control equipment. I couldn't have been more wrong. Oh. It's a right angle drill.
Did you need one of those?
Yeah, I mentioned it in the last video. Oh, he sent me a bunch of Ryobi tools.
Oh, that's cool.
A little mini impact. So there are 8 tools in all. 4 I don't have and 4 that are duplicates, so I'll probably be passing the extras along, and we'll put the new ones to good use. The only problem is now that the rack I built to hold these tools isn't big enough. Alright, we just received a shipment of primer, and I have some concerns about how it's packed, because it seems awful rattly. Well, get that out. Well, no signs of leaking. See if they're any worse for wear on the inside. Well, that's by far the most epoxy I've ever purchased at one time, but it's probably nowhere near what we're going to end up using by the end of this project. So now that we've got more epoxy, I can finish priming those sweeps I started a while back. Now, I've been working on this behind the scenes for probably about a month now, designing the schematic for what I wanted it to do, sourcing components and swapping out components and getting it to the point where I kind of like the layout and I like the functionality. Now, I'm not going to go into depth here as to how this actually functions. Maybe once it's installed in the ride and functioning, I'll explain it more because I can actually demonstrate it. But for now, basically it's going to control the motor, it's going to be able to control the chase lights on the tower, and it's going to power some floodlights, and that's the functionality designed into this, and to do it all in a safe manner. So I'm going to get to wiring this now, and just work our way through it. If we hit any important milestones, I'll be sure to show you what's going on. The only thing we're missing is a Shunt Trip device. And that is a mechanism that kind of hooks as a sidecar to this breaker. And when the breaker's on, that will allow us to electronically trip it. So we're missing that. It's on a slow boat from China, seriously, but that'll mount to the side of this. And if it receives a signal from the operator station, a shunt trip, we can shut the whole ride down just that fast. It was the very first thing I ordered, and it's still not here. But that's not going to stop us from doing our wiring. So I've been chipping away at this thing. I believe I have all the neutral wires run for everything through our main breaker. Still waiting for the shunt. Feeding everything. We have a breaker wired up with the hot lead to feed our 24-volt power supply. And we've got our supply going over to this breaker, which will eventually feed this contactor and then on to the VFD. So little by little, we're chipping away at it. Q4, and it's going to be L2. Q3, L2. I'm really loving this new label printer. I'll leave links down below in the video description to all the tools I use. So we're going to come out of here. There's our Q4L2. Going to go around the corner here. We can probably get rid of this guy. And it's going to feed the relay for one of our lighting circuits. These two relays here are for our lighting. One of them is going to control the light chaser, and the other is going to control the floodlights.
2 weeks later.
Well, after a lot of trial and error, I think I'm finally happy with what I've got here. And this label marker worked pretty well with the heat shrink tubing for wire marking. I like that. So it's time to label some of these things. We're going to start with Q1. Q3 is going to be 10 amp. Q4 will be the same thing. This one is going to be Q0 with our shunt, but after trying to order the shunt from 2 different suppliers on 2 different occasions, they keep canceling the order from me. I think this first breaker is going to need to be changed out so that I have a matching shunt and breaker. So I'm not going to bother labeling that one because I don't think that's our final unit. K1 is going to be flood. K2 is going to be chase. I suppose I should talk a little bit about what this fault override key switch is for. I am following the manufacturer's recommendation, and there's a control circuit in the drive that opens up if the drive has a fault. So they recommend using that circuit in conjunction with the contactor that's feeding the VFD so that in the event of a fault, the contactor will automatically drop out and shut the drive down, which I suppose is a good idea, or they wouldn't recommend it. But the problem with the idea is that in the event of a fault, the drive will shut itself down, there'll be no power to it, so you'll never see what the error is. So with this key switch, once I know that I'm safe to test it, I can override the fault and hopefully catch the error happening. So otherwise, I don't know how we would troubleshoot the system. Maybe instead of fault override, I should call it service. I could see how the words fault override could have a bad connotation. So this will now be service mode. Never run in service mode. Service mode is just intended for troubleshooting purposes. These 2 control boxes will make up the operator station. I didn't want it split across 2 boxes, but it's very hard to find a single box with 8 openings. I want to put this timer relay inside this control box, but in order to do that, I'm going to have to carve out some extra plastic in this box to make it fit. Yeah, that should be good. Boy, that process unlocked a core memory for me. The smell of this plastic melting reminded me of the spin welder I had as a kid.
Spin welder puts power in your fist. Put on the welding rod and actually start welding your race car, section by section.
Anybody else remember those? Okay, so I've also modified a piece of DIN rail here. I had to get rid of the extra height here. Even that was a little too much. But I think now, with those little plastic bosses removed, this will fit in here, and this should fit over top. Yeah, so that's our goal. Man, I can't even remember the last time I thought about spin welders. So that timer's going to set the ride length. This week was a pricey one, and I haven't even talked about this yet, but between the motor and all the components for the electrical panel, it added up fast, and we're not done yet. Next week, we're tackling the racking and jacking system, so the spending spree continues. Big thanks to our Patreon supporters for helping to make this possible, and to all of you who come back and watch week after week, and if you don't want to miss what's coming next, click that link to the left and come along for the ride.